We're asked to find the volume of the solid bounded by the elliptical paraboloid given here in the planes x equals 5, y equals 4, and the coordinate planes. So we'll find this volume using a double integral. So we're going to integrate our paraboloid over the region defined by x equals 5 and y equals 4 in the coordinate planes, which means the region of integration would be from 0 to 5 for x and from 0 to 4 for y, which means this rectangular region here in the xy plane is the region of integration. Before we set up our double integral, let's look at this graphically. So here's the graph of the paraboloid, and again our goal here is to find the volume under this paraboloid above the xy plane over the region of integration, which is a rectangle that we just defined. If we zoom in on the region of integration, we get a much better view. So in blue we see the graph of our paraboloid only over the region of integration, which again is the rectangular region from x equals 0 to 5 and y equals 0 to 4. So when we find the volume under the paraboloid, we're finding the volume here, in this region here, again bounded by the paraboloid and the xy plane over this rectangular region. So going back to our work, let's go ahead and set this up as a double integral. So the integrand function is going to be the paraboloid. We need to decide on the order of integration. Let's integrate first with respect to x. So we'll integrate with respect to x from 0 to 5. And then we'll integrate with respect to y. With respect to y, we'll integrate from 0 to 4. So now we integrate with respect to x, treating y as a constant. So we'd have 5x plus, here we'd have 4 times x to the third divided by 3, or 4/3 x cubed. And then we integrate 3y squared, we're treating y as a constant. So we have 3y squared times x, or 3xy squared. Now we evaluate this antiderivative at 5, then 0, and then find the difference. So when x is 5, we would have 5 times 5 plus 4/3 times 5 cubed plus 3 times 5 times y squared minus, when x is 0, we have 5 times 0 plus 4/3 times 0 cubed plus 3 times 0 times y squared. Notice all these terms here would be 0, so we're left with the integral from 0 to 4 of, here we have 5 squared plus 4/3 times 5 cubed. That comes out to 575 thirds. Then we have plus 15y squared. And now we integrate with respect to y. So we'd have 575 thirds y, and then we'd have plus 15 times y cubed divided by 3, which gives us 5y cubed. Let's finish this on the next slide. So when y is 4, we have 575 thirds times 4, and then plus 5 times 4 cubed. And when y is 0, notice how this would be 0, and so would this. So 575 thirds times 4 comes out to 2300 thirds. And then we have plus 5 times 4 cubed is equal to 320, or 320 over 1. So obtaining a common denominator, which would be 3, we'd multiply here by 3 over 3. So the sum comes out to 3,260 thirds, or as a decimal, this would be approximately 1,086.6667. And again, because this is volume, we could say cubic units. So again, going back to our graph one last time, we just found the volume. Let's pause this. Under this blue paraboloid over this region, bounded by the xy plane, which is this solid here. I hope you found this helpful.